Okay, this is class 4 of Game Programming Foundations 1. So we're going to do a little bit more with Python today, and then I'm going to give you some time to work on the lab. And I just want to get through a few more topics to get you a little bit farther in Python. So let's go ahead and get started, and let's get through that. So here's what we're going to do today. Quick review. We're going to look at some string operations, some arithmetic operations, some conversion functions, some variables, and then we're going to revisit this input function and do some things with it. So let's go ahead and get started today. Okay, so here's a quick review. Previously we looked at a few commands. We had comments, which remember you just say # and anything from that # up to the end of the line gets ignored by the interpreter. It could be a line by itself, it could be at the end of a line of code, but that's how comments work. A null statement, which comes in the form of either a blank line or the pass command, those also get skipped by the interpreter and ignored. But it gives us a way. The reason for null statements like the blank line is so we can space our code out in our programs in a way that makes it a little more readable, like paragraphs in a word processing document that you're working on. The print function we looked at to display things, have it print those out to the console. The input function we looked at, when we looked at it previously, it was just to let it wait till you hit enter before it continues on. And then we also looked at how to do stuff in shell mode, where you type it in, the interpreter immediately takes an action, or script mode, where you edit a file, record all of your program statements sequentially, one after the other, and then run it all at once. Okay, so there's our review. So now what we're going to do today is we're going to start with a few string operations. Concatenation allows us to join two strings together. In other words, I could say hello plus there. That will join those together without a space. The plus sign will just stick this one right after that one and make a new string. So in other words, this is just like an operation on anything. We have a piece of data that's a string, another piece of data that's a string. We say this plus that results in a new string that is both of those now, with the second one immediately following the first one. There's another thing called string repetition, where we take a string and then multiply it by a number. So in this case, blah multiplied by 10 will be blah, 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 repeated 10 times. And let me quickly switch over to a Python shell here. And then we'll just play around with that just a little bit. Okay, so let me go to display capture. Whoa, that's not what we want. Okay, so I'm on the wrong window. Hold on 1 second. All right, well here, I know how to fix this. Let me move this over here. Okay, so here, essentially what we had looked at in that other example was concatenation. So for example, if I say hello plus there, notice I get a new string, hello there. And that will work. I could actually concatenate three things together. This plus is plus a plus test. Now notice that the plus sign in concatenation, it does not automatically insert spaces, so we just get everything all run together into that new string. Now the other one with string repetition, we did blah, blah times 10. And there it is. It's essentially concatenating it with itself 10 times. So repeating it over and over again. And so actually I could do like blah times 20. And now I get twice as many of them. And one thing to notice is that because that produces a string, I could say blah times 10 times 10. Now, what's that going to do? Well, if we think about what that's going to do, it's going to do blah times 10, which is going to give us 10 of these. And then we're going to make 10 copies, repetitions of that. So if I do that, Notice I get 100 of those. I get 10 groups of 10 each, all as one new string. Okay, so switching back to that's kind of cool. All right, anyway, switching back to the slides temporarily here. All right. Now, arithmetic operations. Just like we have string operations, we also have arithmetic operations. And arithmetic operations allow us to manipulate or perform operations on numbers. And as we see here, multiply, you have to use the asterisk between two things. Divide is the /. Addition is the plus. Subtraction is the minus. Exponentiation is two asterisks together. One thing that I want to point out here is you may have come from another programming language that uses the caret symbol, the little the thing if you press the shift key and then the 6, the little looks like a little hat thing. The caret symbol is not exponentiation in Python. It has a different meaning, so just be careful. If you use that, you're not going to get what you think you're going to get with that. Exponentiation uses the two asterisks together. So make sure you're using that if you mean exponentiation. All right, modulus, which is the percent sign. And what modulus does between two numbers is it gives you the remainder of a division. In other words, you get have this integer division that you do, and then say whatever's left over, that's a modulus. And there are a number of uses for that, as we'll see later on in the semester, and as you'll see later on in your career as a game programmer. Modulus can actually be pretty useful for a lot of different things. But the ability to get a remainder of a division, or say what's left over after we've done this whole number of divisions, is what modulus gives you. Now, the other part of that is kind of rather than the remainder, is the kind of quotient, or how many whole times that number goes in. You can do that by //. So the normal / will give you a divide that will result in like a decimal value. // will give you a number that is the whole number of times something fits into that. So for example, if we said 5 // 2, how many whole times does 2 fit into 5? Well, we would get 2. And if we did 5 mod, or 5% sign 2, it would give you 1, because there'd be 1 remainder left over. So this gives you the number of times. This gives you the remainder. So these ones kind of are a similar operation, but one gives you the whole number of divisions. The other one gives you what's left over after that whole number of divisions. And then parentheses are considered their own arithmetic operation, and we can use those for grouping to force order of operations the way that we want them, rather than the way that it is naturally. Now, the Python interpreter is smart enough to perform order of operations correctly, meaning that it will follow the normal algebraic order of operations or arithmetic order of operations that you're used to from math class or algebra class. And that is, just as a reminder, it's the same as it is in algebra. What's in parentheses always are first from the inside parentheses, working their way outward, and then exponentiation from left to right, multiplication, division, mod, integer division from left to right, addition and subtraction from left to right. And notice that I know they use this mnemonic in the algebra classes that you've had. They use this PEMDAS thing, which is parentheses, exponentiation, multiplication, division from left to right, addition and subtraction from left to right. Notice that in the multiplication and division, mod, since that's a remainder of a division, and integer division is another kind of division, those both fall into that same category, even though you may have not seen those or used those before. All right. And I suppose we could make a mnemonic from this PEMDAS thing, like Paul expects Paul expects miraculous deployment and service. I don't know. You can make up whatever mnemonic you want, but notice that it makes sense. If you're used to algebra, if you're used to arithmetic, then it's the same order of operations it used to. And the Python interpreter is smart enough to do that on its own. It will not have difficulty in doing that. And as an example of that, let me quickly switch back over to the Python shell here. And let's take a quick look at what we're talking about. So in other words, if I do 10 plus 5 times 2, now you might, if you go left to right on that, you say 10 plus 5 is 15 times 2 would be 30. But notice that the Python interpreter is smart enough to do the 5 times 2 first, because multiplication and division should happen before addition and subtraction. So we'll get 20 instead. So in other words, this will be 10 plus the result of 5 times 2. Now, if we wanted the 10 plus 5 to happen first, because parentheses happen first, I could just put this here and do 10 plus 5, that whole thing times 2. And now we get the 30 with 15 times 2. So notice that we can rely on the Python interpreter to always perform the, so for example, if I say, what's 2 raised to the 3 plus 4 power, notice that that gives us 12, because it did 2 to the 3, which is 8. So 2 times 2 times 2 is 8, plus 4 is 12. Now, if I wanted to do 2 raised to the 3 plus 4 power, I could do that. 2 raised to the, and then put parentheses, 3 plus 4, which is 7, which gives us 128. So notice, if we want to override order of operations, it's up to us to do that. And notice that if I do 2 raised to the 8th, that gives me 256, because that's the number of possible combinations for an 8-bit number that we saw. Remember, we had those 8 bits with the that can be held in 1 byte. 0 to 255 is 256 combinations. So we can actually use this to say, okay, well, how many can I fit with 16 bits with 2 bytes? Well, 65,536 possibilities. 0 to 65,535. Well, how many could I fit with 32 bits? So 2 raised to the 32. Notice that's 4,294,000,000 and so forth. Well, you're like, how much could I hold in a 64-bit value? 2 raised to the 64. How many combinations are there with that? Notice there's a large number of that. And I don't even know what that is. What's this? Those are millions, billions, trillions, quadrillions. So 18 quintillion, something there. And notice that one of the cool things about Python is it has the ability to calculate, at least in these integers, arbitrarily large numbers. So I could say, well, what's 2 to the, like you've heard of, like 1024-bit encryption. Well, how many possibilities are there with that? And now we get into the really large numbers, and notice Python just seamlessly was able to calculate that very easily. Okay, so switching back to the slides, let's move on. Okay, a couple of other things that are useful for doing arithmetic operations and kind of math functions are these conversion functions that are built in. So ABS, anything you put in the parentheses, it'll take the absolute value of that and give that to you. Int, anything you put in the parentheses, it'll convert it into an integer. And if it's a floating point number, meaning a decimal, it'll round towards negative infinity. So in other words, if I have 0.5 and take the int of that, I'll get 0. If I have negative 1.5 and take the int of that, I'll get negative 2. So it'll round downwards towards negative infinity. Now float does the same thing, but that will convert to a floating point number from a string or from an integer. In other words, what a floating point number is, it's just a decimal number that has a decimal place. And notice it doesn't have to have something after the decimal. So for example, 1.0 would still be considered a floating point number because it has that decimal point, even though it's 0.0. But you could also start like 0.001 or 0.5 or 1.75 or whatever you want in a floating point number. Float allows you to convert to those numbers from something else. str, rather than converting to a number, we'll take something and convert it into a string. And remember what a string is? A string is just a sequence of characters. So if I gave it like 1050 and I said convert that to a string, it would convert the number 1050 into the character string 1 followed by 0 followed by 5 followed by 0. And then pow is a power function. I really haven't written code in Python that uses that because it's a built-in exponentiation function. But if you see that, just know it's the same as raising x to the y power. But you could do it with this function version if you wanted to. Most Python programmers don't. Most of them will use the exponentiation operator. All right, you can also put hexadecimal numbers directly into your code using the 0x notation. So if I put in 0xFF in my code, it will interpret that the same way as it would interpret 255. If I put 0x41, which remember 41 how the bit values are, that's a 64th place plus a ones place, 64 plus 1, 65. And if you remember on that previous quiz that we did where we did those conversions, Python's kind of doing that internally for us. So I could represent numbers in hex format, and it will put them into, it'll interpret them as decimal, just as numbers on its own. All right, a few other ones that are important is dealing with character codes and other types of conversions. So CHR, what the CHR function does is it converts from a number into the ASCII character code. And then the ORD function converts the other way. It takes a character and it gives the code number associated with that. So that gives me the ability to go from a number to a character, or a character to a number, which ASCII number is it, very easily. And then also notice that Python has these built-in things to convert to a hex string or a binary string. And let's just switch back over to the interpreter and try that. But one thing to note is if you try to convert something that can't be converted, you'll get an exception from the Python interpreter. In other words, if I say CHR, which is designed to take a number and turn it into a character, if I give that a string, it'll give me an error. In this case, a type error. It says an integer is required and you gave me a string. So same thing is true on these other ones. If I tried to take the ORD of the number 5, it's not going to work. So in Python will throw an exception and print out that error message. All right, so let's just quickly switch back to the shell here. And let's try a couple of these. So hold on one second here. All right, so to try out a couple of these, let me move this down to there. Okay, so now you should be able to see that. So trying out a couple of these, let's say, let's start off with if I put 0xFF, you'll notice that evaluates it as 255. Put 0x41, evaluates it as 65. So notice that we can do that, or if I do hex of 255, that'll give me this hex string, 0xFF. Or if I say, what's the hex of 0x41, it'll give me this hex string, 0x41. So we could convert either way. Now notice we said you could do binary as well. So if I do binary, bin of, I think I had 129 on that other page. Notice there's the 8 bits that go with that, 0B. Notice that binary numbers, you can, just like with hex numbers, you prefix it with 0x. You can do that with binary with 0B. So actually, I could type that into. So 0B 1111 1110. Notice that gives 254. So if I say, what's the hex of 0x or 0B 1111 1110, 0xFE. So notice that Python has built into it these ways of like converting between things very easily. All right, so let's switch back to the slides. And moving on from there, we now come across this concept of variables. And variables are going to be an integral part of any program that we write from here on out. The reason being that one of the major components of a computer system, if you remember, was the memory. In other words, it's a memory, it's a processor. The processor can get into the memory and do stuff and store things and retrieve those things. But the question is, how in programming can we take advantage of that memory and store things that we want to store in there? Because if you think of a game, you might need to store things like how many hit points do you have, or what's your health level, how much shield do you have, how many bullets do you have. All of those require us to have the program remember things, and that's what the concept of variables are going to allow us to do. Now, if we look at the word variable, though, just in the kind of the English language usage, like, oh, the variable weather conditions on the lake today. Essentially, that means something that can change or is changeable, likely to change, maybe even unpredictable, might change without warning. Weather conditions will be variable. There'll be variable winds today. That means it might be calm, and then it'll be gusty, and then it'll be calm again. So you just got to be careful. So it's likely to change without warning. Now, that's not quite what we're talking about in programming, as we'll see in a second. But there's another usage you're probably used to, and that's in algebra. Variables in algebra you're used to, like the equation for a line, y equal mx plus b. In this case, 5x plus 7. We have this variable x, and we have a variable y. So an algebra variable is like an unknown. It has no fixed value. It really is a representation of anything we could plug into it. So for example, what's x here? It's anything that we could plug in, any number, any real number that we could plug in for x here. And that's why you get a line out of that, because it's anywhere along that line. Now, in programming, it's a little different. So what does it mean in programming? Well, let's take a look at that. So in programming, a variable is just a name that we are assigning to some data that's stored in memory. So rather than having to remember what address it's at, we just give it a name. So to create a variable, we use an assignment statement. And those are really easy. We just use this equal sign and we give it a name. So x equal 10.5 says create a variable called x, and then assign it in that place in memory, stick the number 10.5. The decimal number 10.5 is now stored in x. So somewhere in memory is this 10.5, this number, stored in memory, and we're just going to refer to it by the name x. But notice we can also make variables that hold other types of things. Like here's one holding a string, name equal player1, or score equal the integer 100. So we can make whatever variables we want to store the things we want in our program, and we just have to use the assignment. All right, one thing to note about the assignment is it's not like in algebra where it doesn't matter which side of the equal sign it's on. In an assignment, the variable name has to be on the left-hand side, and it's the only thing we can have on the left-hand side. So in other words, I couldn't say 10.5 equal x. That wouldn't work. And the reason for that is it's not in a quality like it is in algebra. It's not like in a quality relationship we're defining. We're actually defining this name or assigning that name to refer to this piece of data. So it always has to be variable on the left, thing that we want to assign that name of that variable on the right. Now to access those variables, once they've been created, we can just refer to them by name. Now notice the name has to be not inside of double quotes because it'll interpret it as a string. It has to be out here. But if I wanted to print out the name and the score, I can do that by just using the name of the variable. Now, the name of the variable has to have been created, otherwise I'll get an error. The Python interpreter will like, I don't know, I don't have a variable called that. I don't know what you're talking about. So for example, if I say x equal 10.5, and then on the next line I say print y, well, there is no y, it hasn't been created yet, then we'll get an error. The Python interpreter is smart enough to know what names it has defined and which ones it doesn't, and it will give me an error if I try to use one that doesn't exist. And it'll usually say like name error, that thing is not defined. Okay, so to create a variable, we just use the name and the assignment operator, which is just equal sign, and we assign some data item to that. So notice that variables can hold different data types. It can hold strings, numbers, and the numbers could be integer numbers or decimal numbers. And as we'll see later on in the course, later on in the semester, variables can hold really data of really any type we want. We could use a variable name to hold a list of things or groups of things. As we'll see later on, variable names are the ability to make variables to store data in memory is actually a very powerful thing. And later on, we'll use it even to store pictures and sounds and things like that. But for right now, just think of it as strings and numbers. We'll see the other types later. Now, you can have a lot of different variables. So you could have something that's keeping track of how many bullets you have, how many experience points you have, how much gold you have, what items are in your inventory, what level you're on, the name of your character, pretty much whatever you want to store. And remember, one of the cool things about computing or modern computers is they have a whole lot of memory. So you can store a lot of stuff in the memory of the computer. And the idea there is don't feel worried about if you need to store something for your game. Make a variable and store it. And one of the other things that's important to note is variables, once they're assigned, they could be reassigned later. So if I, for example, said x equals 0 or score equals 0, later on in my code, I could add to the score and then change what's in that variable. And I guess that's the part that makes it like the English language usage of the word variable, changeable, except it won't do it on its own. It's not unpredictable. It's if we want it to change values or change what type of data it's pointing to or what data item it's pointing to, we have to write the code that does that. And we will see a couple of other types of assignment operators besides the equal sign. There's a set of them called the modifying assignment operators that we'll see later on in the course that let you, for example, score equals score plus 1. So you pick up a thing, or maybe you finish a level, it wants to go to the next level, level equal level plus 1, or level plus equal 1. We'll say level was 0, now it's level 1. And you finish that one, it goes to level 2. Finish that one, it goes to level 3. But we'll look at those in a subsequent lecture. But the assignment statement, the one that we've been using so far, always looks like this. The variable name that you want to assign, and then the data item you want to assign it to. And these quotes don't have to be there. It could be in quotes, it could be a number, it could be a string like we have here. It could be a lot of things. Now, one thing though, this name for the variable that we choose for the variable, there's some rules for that. So in other words, we have to give a name for the variable that matches the rules for variable naming. So let's take a look at those. So the rules for naming variables, the first one is it has to start with a letter or an underscore. In other words, the name can't start with anything other than a letter, meaning A through Z, or the underscore character. Those are the only two character types that we're allowed to start a variable name. That's rule 1. Rule 2 is that the entire variable name can only be composed of letters, meaning A through Z, underscores, meaning the underscore character, and digits, meaning 0 through 9. In other words, we're not allowed to have any other funny characters like exclamation mark or @ sign or $sign or parentheses or semicolons. The only things we're allowed to have, letters, underscores, and digits. The third rule is that the variable name cannot be or should not be the name of a Python keyword. And as we'll see later, for example, pass or print or input, we should avoid using words that already have a meaning in Python. And some of them it'll let you change the names of, for example, like print. But that's going to create problems if you ever try to use print after that, because we've essentially overwritten what print was doing with something else that we didn't intend to. Or input, if I say input equal 10, I can't use the input function anymore because I've used that name now for something else. So we should not use a keyword for variable names, and we should not use any of those kind of Python built-in functions for variable names. One other important thing to note is that the variable names are case sensitive. And you might say, well, what does that mean? That means a capital A is different than a lowercase a. So in other words, if I write the variable score, all caps, like I'm shouting it, as capital SCORE, that's going to be a different variable than all lowercase, a C-O-R-E. So it's not just the letters, it has to match the case in order for it to be considered that same variable. So I have seen beginning programmers make that mistake where they'll capitalize in some places and they won't capitalize in other places, and the code will not it'll either crash or it'll work and have two separate variables that are unrelated to each other, where you have the score equals 0 where you used a capital S, and then later on the code, when you pick up things or finish a level, you have score plus equal 1, but you did that with lowercase s instead of capital S. The score now won't increase because you're dealing with two separate variables when you thought there was one. So just watch out for that. Now, in addition to those rules, so these are rules that the Python interpreter enforces. But there are also some things that we should do with variable names as good programmers. So in addition to the rules, good programmers tend to follow some good programming practices or best practices. So good practices for naming variables essentially are: be descriptive. In other words, don't use like PS when you mean player score, because when somebody looks at your code later on, or when you look at your code later, you might forget, what does PS even mean? But player score is pretty unambiguous. That's very descriptive and clear what that means. That's probably the score for the player. Or you might have player health, or you might have level. But rather than using L and PS and PH and PP and XX and IJK and QWERTY, try to avoid using throwaway variable names like that and use something more descriptive. The only case I'd say where it's okay to use something that's like a throwaway variable name is if you have something that's counting through things, maybe use I. If you're having something that you're calculating temporarily and you're not going to, just use like the variable name temp or something like that. All right, the second part of this is to be consistent. And what that means is adopt some sort of style and use that style throughout your program. So in other words, you probably want to use player score, and this is called camel case, where you run the words together but capitalize the beginning of the second one. So player score and player health. That's probably better than using player underscore score and health of player and player underscore level. So you want to be consistent. So that way you know, okay, this is the player score. That's player score. What's their health? Player health. What's their level? Player level. What's their ammunition? Player ammunition. So if you do something consistent, it's going to make your life easier as a programmer. It doesn't change anything in the way the program runs. It's just going to make your life as a programmer, or anyone other programmer who looks at your code ever again later on or as part of your team, it's going to make their life much easier. One other thing is, though, even though we said to be descriptive, don't make the variable names too descriptive or too long. So you want to avoid names like I have there, like this underscore is underscore the underscore players underscore health underscore in underscore my underscore amazing underscore game. That's just too much. And every time somebody wants to use that variable, meaning you're going to have to type all of that out. The second part about that being overly descriptive is it takes up a lot of space in your code, and it makes the code harder to look at. So when you go to edit the code, you have to read all of that stuff, and your brain has to see that and comprehend it. And so the idea is, if you can be descriptive about that variable in a shorter amount of kind of variable name length, then I would suggest doing that. But don't go to the extreme like up here with PS instead of player score, because player score is the short, it's concise, but also describes what that variable is doing, which is what we want. Okay, also avoid starting variables with the underscore character unless you know what you're doing with that. And it's not really that that's bad or disallowed. It's just that Python internally uses certain variable names that start with underscore with a special meaning. It assigns a special meaning associated with this. And so don't just haphazardly name your variables with underscores. Also, I'd say avoid starting your variables with uppercase letters like capital health, because that also has by convention, a use in Python that other Python programmers tend to follow. And if you're programming as part of a team or a company that's doing programming for some project, I would suggest following the style guide for that organization. And most organizations, like you think of like Google or Microsoft or Bethesda, they'll have a style guide for whatever language you're working on or have adopted that, meaning they'll say, well, do I use an underscore for player underscore health or do I use player score camel case? And there's a style guide that says, hey, for our project or for our company, we use this style guide for naming variables. And we're probably going to mix and match and use both of these depending on where we are in the class and what we're doing. And really, these are the two predominant ones. You put an underscore between the subwords or you camel case the subwords. One of them requires an extra character. One of them requires you to hit the shift key partway through. But be consistent. And if you're on a project that has a style guide, follow it. Okay, last thing I want to get through today is a little tiny bit more with this input function. And the idea here is now that we can store data in variables, let's revisit that input function, look at other things we can do besides waiting until enter was pressed. So it turns out that what input does is it not only lets you type things and then hit enter and then continues on, but you can actually capture what that function returns so you can have access to what the user typed in on the keyboard. So here's a quick example. I say name equal input, enter your name. So this is the prompt string that's going to show up. It's going to wait and we can type stuff in. It's going to show up after the prompt. So I could, for example, could type Paul. And when I hit enter, that's what's going to get assigned to this variable. So that what would get printed would be, hello there, Paul. And one thing to note is that that input function always returns a string, and the string it returns is the sequence of characters you typed on the keyboard before you hit the enter. Now, one quick thing to watch out for, though, this is a bug alert, is that because the input function always returns that string of characters, that means we sometimes have to be careful. So as an example, let's say we do this. We say we have feet equal input, enter a number of feet. So that's waiting for us to type in that answer, and it's going to capture that whole thing, but it's going to capture it as a string. So if I have that string and I say, let's say I type in 100 into there, then what's going to get printed, it'll be 100 feet is, and then 100 times 12. Well, we might be thinking in our head, well, 100 times 12, that's going to be essentially 1200. But when we run the program, we get this weird thing. We get all of this. And the reason for that is because when we typed in that 100, it came in as a string. And because that came in as a string, that means when it goes to show all of that, and we do this multiplication, that's doing string repetition. So we're take the string 100 and multiply it by 12, which now we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those all run together. So why does that happen? Because that input returns a string, and the string 100 times 12 performs string repetition, concatenating 100 with itself a total of 12 times, rather than doing multiplication of 100. So the question would be, well, how could we fix it? How can we make it so that something we read from input gives us numbers instead of a string? And the answer is we need to convert that string into a number somehow. And so quickly, do you remember anything that we've talked about earlier today that does conversion into a number, either a floating point number or an integer number? And the answer to that is to use one of those two functions, the integer conversion or the floating point number conversion function. And then what those do is they'll take some other data item, like a string, convert it into an integer if it can, and give us that number as a result, the whole number as a result. Same thing is true for float. The difference between int and float, again, is integers are whole numbers. Floating point numbers can include fractions. Okay, so here are a couple examples of a way we could fix that with that other example. We said read that into feet, and then take that on the next line, convert feet into a floating point number. and store that off back into feet. So we've overwritten it. So now we have a floating point number of feet. We could have used int here as well, but we'll just use float in case somebody wants to type in like 12.5 feet or 1.5 feet or 0.5 feet. But what that does is it's going to take that number, multiply it by 12. And that is a number now. So when I do this multiply by 12, I'm not doing repetition. I'm taking a number times another number. It's going to perform the multiplication and print out what we want to print out. Now, another way we could have solved that is done down here, where I let it be a string, and rather than changing the variable that it's in like I did up here, I just change it before I do the calculation. And then the last one up here is I use the float function around the entire input itself. So I'd say input, enter a number. They'll type whatever that returns. It's going to get that. This, when I pasted in there, it lost a parenthesis. Let me just fix that here just really quickly. Okay. And then we print that out. Notice that we just use feet here because this has to be a floating point number because I converted whatever that returned into a float. Oops. Okay, so that's all for today. I want you to work on that lab, and also I would be ready for a quiz next class. If I were going to study for this hypothetical quiz, I'd probably look at like variable names, maybe look at the arithmetic operators and the order of operations. That might be important. But make sure look at string operators. So basically everything that we talked about today. There wasn't a lot of material today, so look at that stuff. Go through those examples that I did in here, and maybe study those things a little bit and be ready for that quiz for next class. Okay, that's all for today. Everybody stay safe. And again, study the stuff, be ready for that quiz.